Hello and welcome to the Cisco Support Community Expert Series webcast. I'm going to go over a few housekeeping notes before we begin. As you enter the WebEx console, you'll either join us via audio broadcast or by phone, which was automatically muted because of our large audience and attendance today. You will remain muted throughout the event. When you have a question, please feel free to enter it into the WebEx Q&A panel located in the bottom right corner of the console. Please leave the chat window available to communicate with the WebEx facilitator for any problems or issues you may experience today. We would appreciate your feedback on today's event by taking the short survey that appears when you close your browser at the end of the event. My name is Francine Richards, and I'm the Web Marketing Project Manager for the Cisco Support Community, and I'll be moderating today's event. Today's topic is Troubleshooting SIP in Cisco Unified Communications, deployments with Cisco Designated VIP Ayodeji Okanlawon. Our expert joining us today is Ayodeji Okanlawon. If you frequent the Cisco support community, you may have seen Deji passionately answering hundreds of questions within the collaboration. The lead consultant engineer for global solutions and engineering at Verizon Business. In his past, he has worked at Intact IS, NCS Global, and Schlumberger Information Solutions. His experience includes development of design and deployment of large-scale IP telephony projects on Cisco Call Manager platforms, Cisco Voice Gateways, and Cisco Jabber Cloud and on-premise solution. His expertise includes SIP solutions, cube design and deployment, troubleshooting voice gateways, Cisco Unified Communications Manager, Unity Connection, CUPS, and Deji has been awarded the Cisco Designated VIP in 2013 and 2014, and we'd like to congratulate him at this time as he was just announced as a 2015 Cisco Designated VIP as well. And Deji holds a Bachelor of Science in Electrical and Electronics Engineering. Welcome, Deji. And joining Deji today are subject matter experts Rafael Pardinas and Lavanya Panaselvam. Rafael is a senior UC&C design engineer focusing on the Cisco Unified Communications and Collaborations portfolio. He works on pre-production and production design and architecture, UC&C models, and he is involved with existing and upcoming solutions on Cisco's UC portfolio, working on creating a design model ready for implementation. Lavanya is the Cisco Support Community Manager for the Voice and Unified Communications domain. She focuses on voice and unified communication technology and drives content collaboration and growth of the community with customers and partners. She is an engineering graduate in electronics and communication technology, and since 2002, she has worked within the telecom industry with extensive experience in IP telephony, public switch telephone networks, next-generation voice networks, and GSM wireless technology. And now let's take a moment to review some upcoming events which might be of interest to you. We have a very special three-part in-depth webcast covering Cisco Nexus 1000V series switches. Part 1 will be on Conquer Territory Multi-Hypervisor on February 12th. Part 2 will take place on February 17th. Meet the 1000V family, the secret of unity. And closing out the sessions on February 24th will be Game Changers, Silver Lining in the Cloud. And if you're interested in that, you can go to the link in the chat window. And we have ongoing Ask the Expert Q&A discussions on the Cisco support community running every 2 weeks. Our current topics available for your questions are Cisco Catalyst 6800 series switches and understanding, implementing, and troubleshooting Cisco Prime Network. Those two Ask the Expert events will run until January 16th on the community. And yes, we are returning to Cisco Live Milan, which is running from January 27th through the 30th, and you can visit us in the World of Solutions in the services area and can find out more information about the community and some of our portfolio offerings, including Cisco On Demand and Connected Analytics for Social. Deji will be continuing the discussion in the Ask the Expert event following this broadcast, and that will take place through January 23rd. So if you have more questions, please visit the knowledge sharing area in the Cisco support community or reference the link in the chat window. Now, I'd like to briefly outline the format for today's Expert Series webcast. Deji will start with his presentation and demo for the first 60 minutes of the program, and then we'll dive into the live question submissions for the remainder of today's event. During our live presentation, you may submit questions to be answered by Deji and the team of Cisco technical experts using the Q&A box on the right-hand side of your console. The team of technical experts is well-versed in SIP and unified communications, so please begin posting your questions now to give them the best chance of answering them. We'll be asking polling questions during this webcast, and we highly encourage you to participate by answering them. You may download a copy of today's PDF presentation using the link in the chat window. And now we'll get started with today's event. We'll start off with a polling question for the audience. Do you have a SIP deployment within your UC infrastructure? A, I have a SIP trunk deployment, Cube, UCXN integration, ITSP, etc. B, I have a SIP line deployment, Jabber, on PREM, MRA, SIP, and endpoints. C, I am using SIP with VCS, CE, CUSP. Or D, I am planning on migrating to SIP trunks, SIP endpoints, SIP on VCS, CE. So please take a moment to answer that, as this will give Deji an opportunity to tailor his presentation to meet your needs. Now make sure to submit your questions, as we'll be answering them later in the webcast. And now I would like to hand the mic over to Deji, who will start the presentation.
It's a pleasure to have you here. I do hope that you enjoy it. It's going to be fun. I believe it's going to be fun. But most importantly, I believe it's going to help us in our journey as we walk through our way within the UC infrastructure. Okay. So feel free to submit your questions. The questions just help us to see, get a gauge of where you are within your SIP deployments, what you use your SIP deployments for, and all that. That's really what was meant to show. Okay, so we will be looking at troubleshooting SIP in Cisco Unified Communications deployments. Okay, and I have decided to make it as elaborate as possible because as we look around us today, we find that SIP is beginning to shape and redefine our UC world. It is beginning to shape how we deploy and implement solutions. So, and I just feel it's imperative for us, especially we UC engineers, to begin to strategize, to begin to position ourselves in such a way that will be relevant not just for today, but for the technology of the future. Today we'll be looking at understanding the SIP architecture. We'll be looking at understanding SIP traces. We'll be looking at troubleshooting methodology. And most importantly, we'll be looking at case studies, scenarios where all of the things we'll talk about today, we will see how they all come together in resolving problems. Developing an expertise in SIP will ensure you are strategically positioned career-wise for the next decade. I see this protocol being around for a long time, and so it will mean that it will imply that for you as an individual, your career is future-proof. Okay, you see over times where people they get stuck in the past within their areas of expertise or areas of development or career, and as the years roll by, they become irrelevant. But for you, if you take a deep dive or if you take a closer look at SIP as it unfolds, and you ensure that you plug yourself in, what that means is that you invariably secure a form of future for yourself within the UC world and the UC solution. Where do we find SIP protocol today in our UC infrastructure? It's amazing because everywhere you look around today, you find SIP everywhere. I use the statement, everywhere it's become SIP-y. It's like there's a SIP world out there. It's a SIP-C out there. Everything is SIP. You have third-party endpoints developed on SIP. You have free PBXs on SIP. You have Asterisk on SIP. You have it's not even just Cisco solutions now that are heavily dependent on SIP, but you find everywhere around you everything seems to revolve around SIP. Okay, so we find SIP in our SIP endpoints, Java, IP phones, video endpoints, especially the new series of the DX series, great video endpoints. They all run SIP today. We find SIP within our call manager, SIP trunks, either our intercluster trunks or our gateway SIP trunks or cube SIP trunks. We find SIP there. And very, and of recent, we say that people are beginning to shift from skinny integration with Unity to SIP integration, okay? And within VCS and VCSC and VCSE, we find SIP also in there. Within our Expressway, which is, a subset of VCS, as we know, and especially for the Java mobile remote access solution, we see SIP being heavily utilized there also. We have CCME SIP endpoints, we have CCME SIP trunk, CUE SIP integration, and also within the multi-conference solution, the multi-conference telepresence solution, talking about the telepresence servers, talking about conductors, the MCUs. We find SIP embedded in each and every one of these solutions. So this further underlines the significance of this protocol today for us. So what is the fuss really all about? Why is everybody SIP crazy today? And you will be shocked to find out that SIP actually still a lot of the concept of SIP is stolen from HTTP. And as you see, as we discussed this, or as some of you already know, a lot of the SIP, you see for example, a SIP URI or a response code, they are actually borrowed from the, World Wide Web, the HTTP protocol. So that's where you could say it emanates from, as it were. And you're going to see a lot of similarities between SIP and what you know as a web server today, or, the client sends a response, a web server, the web server sends a response back. You see some form of similarity in there. So this is another set of polling questions, and like I said earlier, the polling questions help us to gauge where you are so that we can help tailor the presentation properly. Now, what is your level of understanding of SIP architecture? Is it A, you have a good understanding of SIP? Is it B, you have a solid understanding? Are you new to SIP, or perhaps you may be an expert on SIP? Okay, in which case, then I have to really watch what I say if I have an expert there, So I hope I don't have a lot of experts out there. Okay, let's go into the core of the SIP architecture. SIP is defined in RFC 3261 through to 3265, and there are many more RFCs. I'm going to pause here and just say a few things about the RFCs. RFCs are basically requests for comments, and they provide a framework through which each vendor define or develop their SIP protocol. What this does is it gives us a set of guidelines to say, okay, this is how this is how we're going to develop or write our SIP protocol, so that my equipment or my infrastructure or my gears can work with yours. The RFC basically provide a framework, some form of standardization that different vendors can use to develop SIP. And this is very crucial. This is very critical because everybody, I can't just get up today and say, this is how I'm going to define my flavor of SIP. And then you stand in your own world because your SIP is not compatible with other, the other party SIP. And then you find out that, okay, all right, these two equipments, they can't talk together because there is no form of, no interoperability in any way. I'm also going to say something about RFCs because you see, guys, traditionally we're not programmers, so you don't want to go look at an RFC. However, if you want to understand the protocol a little better, if you want to get closer to the technology, you need to take some time and look at RFCs. RFCs can be critical, especially even if you're troubleshooting something. You want to see if this party, this service provider, is following the recommended approach. Are they defining, have they written their codes in a way that is compatible or that follows the recommendations of the RFC? So, and each component of SIP protocol, you're going to see along in the slide, have some of them have specific RFCs dedicated to them. Okay, SIP is an application layer protocol. It is used to establish, to modify, and terminate multimedia sessions. We have and when I talk about multimedia sessions, I'm talking about audio, video, and also I'm talking about content sharing. Okay. SIP also use things we call SIP message, and a lot of us must have heard about SIP messages. Okay, and within a SIP message, we have what we call a request and we have a response. So SIP is basically I send a request to you, I expect you to send a response back to me, and within that, within the framework of that, we have this critical component that we call SIP headers, and we will look at some of the SIP headers today. SIP uses SDP for media negotiation. Okay, SDP stands for Session Description Protocol. In H.323, the protocol that most of us are familiar with, there's something called the terminal capability set. So in H.223, we have our H.225 signaling, and we have our H.245 part of the protocol that we use to negotiate media. So this is why SDP come in for SIP as well. And I've put in here it's something that maybe a few of us may not be familiar with. It is called the RTP AVP profile number. AVP stands for Audio Video Profile Number. And this defines a set of attributes that says, within my SDP, this is how my codecs should be mapped. They are mapped to a certain number. So when you're troubleshooting a SIP related issue, okay, you're looking at your SDP, you're looking at the capabilities that have been offered or that you've received. You're able to interpret and say, this number is for this, that number is for this, okay. And like I said, SIP was built, or, a lot of such concept was taken or borrowed from HTTP. So it's a client-server relationship. You have a client that sends a response and you have a server. Sometimes in between you can have a proxy, which just sits in there relaying information back and forth between the client and the server. The SIP messaging has three main parts. We have the start line. The start line basically is your request and your response line. You have a header, and then you have a body. That's how simple as it is. Of course, within all of these, there can be several components to it, but this is what you need to understand. There's a start line. For example, I say invite SIP. That's my start line, okay? And then my response says 200, okay? That's my response. And then within that, what follows that then comes all of my headers, my to headers, my from, my via headers, and all of that. And then goes my media or capability negotiation, which is called the SDP. SIP uses methods to generate requests, okay? There are 6 basic methods in SIP. There are so many others, but we have 6 basic methods. One of it is an invite. An invite method is used to establish media sessions between user agents. It is similar to a setup message in ISDN. That's what an invite is. It's a method that says, I'm going to use this method to establish a media session between myself and the other party. It's as simple as that. An ARC confirms that the client has received the final response to an invite request. An ARC, that's what an ARC. And the buy is what we use to terminate a session in SIP, okay? We have also a cancel. A cancel spending request. It is different from a buy in that the session, we use a cancel to cancel a pending request when the session is not already established. Okay, that's the difference between a buy and a cancel. And then we have options. And an option method is used to query the capabilities of servers. A lot of us are familiar with options ping today. We use options ping as a means, as keep-alive today, to measure or to monitor the status of a trunk or of a server, for example. And they're becoming very popular today. They're recommended in our deployments because they give, automatic failover. For example, if I know that my SIP trunk is down, then and I have a fallback SIP trunk, there is no point me sending an invite to that SIP trunk. Why not just use an option thing and say, okay, that trunk is down, I'm not going to send any traffic to it. I'll use the backup instead. And then we have the register method, which registers the user agent with a registrar server of the domain. There are many more SIP methods defined in different RFCs. And we have the prac method, we have info, we have update, we have subscribe, notify, refer, publish, and message. All of these are referred to as methods in SIP. Now, generally, we have two types of methods. We have what we call the invite method and a non-invite method or non-invite request. Okay, invite, as we know, it's an invite. And what differentiates the two? There's a reason why I'm mentioning this. In an invite, what differentiates the two is that invite request, we get two things from them. We get a trine and we get an arc. A non-invite request, you shouldn't, according to RFC, you shouldn't get a trine, 100 trine, and you should not get an arc. So sometimes when you're troubleshooting, you get a subscribe message or a register message. You're not going to get 100 trine for that. You're just going to get the method and then a response, a 200 OK, for example, and you're not going to get an arc to that 200 OK. Okay, so that's the difference between an invite and a non-invite request. Let's look at SIP response codes. We have the 1XS, which is provisional. So you have, the 100 trying, 180 ringing, 183 session progress, and then you have the 200 OK, 202, your notification is accepted, and you have, the 3XS, which we use for redirect, and then you have, the 4XX, which says, a client has made a mistake, for example. You could have 404 not found. You could have 401 proxy authentication required. And then you could have 5XS server failure. Now, as you look at these are synonymous with some of the response codes that we find in HTTP protocol, okay? However, there's one that is different. It is only in SIP that we have the 6XX global failure. And the first time I saw this one was on the forum the other day, and guess what? It was a link deployment that had a 600 global failure. And I thought, if we're going to have a global failure, where else will it come from if it's not link? Well, I know there are link guys out there, so please pardon me. And if you wish to shoot me, I guess, I'm protected by the fact that you can't see my face, okay? So, you can go ahead and shoot your computer. Anyway, I'm a Cisco-centric guy, so I love Cisco, and I was really delighted to see that I could see a 600-something global failure on a link deployment. Now, there's a rule of thumb here. Everything in caps is a request, and everything in number is a response. You have to have this at the thumb, at the palm of your hand when you're working with this. Everything you say, when you're looking at your tracer, you will see your invite comes in caps, your subscribe, your notify, your publish, your message. They come all in caps. They are requests, okay? And there's another one, an arc also is a request. So that's why it's always in caps. And everything else a number is a response. That's the rule of thumb. Have that and know that. And one of the reasons why I'm saying you should know this, you should know that, is because when it comes to troubleshooting difficult problems, your knowledge of the protocol stands out. It just separates you from the guy who just knows it in passing and from the guy who's done a little bit of his homework, who's done his due diligence, and who knows exactly what he is talking about. It's a big difference, and I feel the onus is on us as UC engineers. This is what pays our bill. This is what we build our career, our future on. We might as well do it well. Know this stuff and know it very well. Okay, let's go on to SIP request and a response. This is the format of a request, and this is the format of a response. In a request, we have a method. We have a URI. Okay, we have a SIP version. Okay, the URI, we call it RURI, or the request URI. Okay, so we have a method. The method could be a register, for example. Then the URI, then the SIP version, and then we get a response that says, okay, and the response goes, it comes with a SIP version. We get a response code and a reason. For example, when I send a notify, I get a response, a 202 back, and then I get a response code of accepted. Or if I send an invite, I get a 200, then I get a response code of OK. So this is an example of a request line. I get an invite SIP. I say the number. This is my URI. Talking about URI, so the URI is divided into two portions. You have the user portion and you have the host portion. The host is who hosts the user, basically. Where can I find this source? Who is responsible for this entity? A URI is a uniform resource identifier. It's unique for an entity. So you say, okay, on this host, on this server, this user exists. That's our URI there. So this is what we see in a request now. We see an invite, we see the protocol, and then we see our URI. We see the port, and then we see the SIP version that we are using. I hope you guys are still with me. No one's sleeping on me, okay? All right, thanks. Now, this is a response line, right? We get, and as we've discussed earlier, we see our reason code and we see our free text reason. I've just put it here to make it clearer for us, okay? Now, I'm going to be talking about SIP headers here. This is very crucial because everything we do in SIP, we formulate our invite, our response using our SIP headers, okay? And there are a few of them here. There are 6 mandatory SIP headers. We have the via, the from, the to, the maximum forward, the call ID, and the C sequence or the command sequence, okay? Now, other headers can be mandatory as well, depending on what function is being performed. And I'm going to, give us a teaser here. The contact header is mandatory for an invite and a 200 OK to the invite. I'm just going to leave that open for you. Why is that? We will come to it later on, but I just want to get you thinking. Why is the contact header mandatory for an invite? Okay, let's look at the via. There's a rule of thumb in SIP, and the rule is responses follow the via. If an if a client sends a request, he puts in a via header because that's where he wants to get his response. So responses follow the via header. Now, the to and from header, obviously, the from header identifies who the request is coming from. The to says this is where the request is going to. I'm going to say something on the to and from header because oftentimes this is a little confusing. The to and the from header are not reversed in the response message as one might expect them to be. This is because the to and the from headers are defined to indicate the direction of the request, not the direction of the message. So don't expect, if I send an invite to this person, so when the response is coming back, we're asking, oh, why is that? Why is this coming from this? No, it's not coming from the direction of response. We're looking at it from the direction of the invite. So that's what the tool, that's for the tool and the from header. And also something to mention about the from header. Sometimes we can't use the from header for CLI to display CLI. It's very rare. In SIP, we use either a remote party ID, P preferred identity, or P asserted identity to display the caller ID. Okay, but if any of those, if none of those are present within your SIP headers, then you will have to use your from header to display the caller ID. The command sequence is very important. And the command sequence is basically it's a numeric figure, a number. It's a count, a sequence count. It is used by the user agent server to determine out of sequence request or to differentiate between a new request, which will mean a new command sequence, or a retransmission, which is the same command sequence. So it is very, very important for whether you're a client or a server to include the correct command sequence in your request or your response. Okay, the server uses it to identify if this is a retransmission, for example, and we're going to see this on one of our call flows. Your command sequence, if it's a retransmission, it remains the same. If it's a new request, it is different. So the server that is responding to that request, like dealing to that request, he knows that, okay, this is a retransmission or this is a new request. As for the user, the UAC, the user agent client, it uses the command sequence to match a response in the request references. So if I'm going to send 100 trying, a 183 or a 200, okay, the command sequence has to match the request that response is for. Okay, we will see this graphically so we can get a better understanding of it. Okay, so this is a sample of a SIP trace, and we can see all of our headers here. We see the via header, the remote party ID, the from to. Just going to mention and highlight a few things here. Okay, so your call ID is very important when you are troubleshooting a SIP trace. Okay. This is because your call ID identifies uniquely a session. So you turn on your logs and you're looking at call manager traces, for example. You have so many sessions going on in there. How do I trace and identify that this is my correct call? Okay, so the call ID does that for you. It helps you to uniquely trace one call leg and to differentiate that from the other call leg. For example, in a queue, you're going to have two call legs. You're going to have, an inbound call leg and an outbound call leg. Your call ID is going to help you to identify, okay, this is my inbound leg, that's my outbound leg. Okay, there's another header that I like here. I'm going to identify. It's called the user agent. It helps you to identify what kind of vendor or who is actually originating this request. In this case, you can see this invite or this request originates from a Cisco SIP gateway. You could say in that place 3BX something. You could say a vendor, and it also helps you to know the version of the software that vendor is using. Okay. Now let's look at the session description protocol. I did mention that we use this for capabilities / media negotiation, and so we will look in detail in this. Okay, SIP uses the offer answer model as described in RFC 3264 to negotiate media using SDP. So SDP has its own RFC, and it is 3264. RFCs are important. They are very, very crucial in deploying any protocol, especially this protocol. We need to know how we're going to interpret what someone is offering me. If I, as a Cisco software engineer, for example, if I'm going to write my scripts, I need to know how someone who is on a free BX switch, for example, is going to interpret what I'm offering to them. And that's what the RFC does for us, gives us a common ground to operate from. So the concept of an offer and answer model is there. One endpoint sends an offer in its SDP containing all the capabilities the endpoint wishes to negotiate. So I say, hi, my name is Deji, okay? I love to scuba dive. I love to fly. I love to skate, okay? And you say, hi, I'm Inspector Clouseau from Pink Panther. I like to arrest people. You know, you say, okay, I can do this. Or, oh, hi, my name is, you know, my name is Goofy, and I like to do ballet dancing, for example. And I say, okay, that's nice. I like the concept. You know, you like to dance. I like to sing. I like to, you know, you like to jump. I like to crawl. Okay, you like scuba diving. I like to do kite surfing. And you're like, okay, is there any common point, any common ground between us? Is there a place that we both agree? Is there something we agree on? And you say, okay, sorry, nothing, bye. Okay, you know, so obviously it won't, you know, things won't work like that. We have to find something that we agree on, okay? SDP contains what we call M lines or media lines for each media stream that are being negotiated, okay, i.e. audio, video, or content channel, or what we call applications, okay? Each receiving endpoint sends an answer in its SDP that contains the same or a subset of capabilities received in the offer. As per the RFC, for each M equals line, the offer, we must send a corresponding M line. This is important because so if I send two M lines, for example, that contains one M line contains audio and one M line contains video, I have to get a response back for both the audio and the video. If I send three M lines, I say one M line is for audio, one is for video, and one is for application for content sharing, I have to respond to that. Otherwise, something won't work somewhere, okay? And why am I emphasizing on all of this? You know, you could say, well, I don't want to care about M lines. Who cares about M lines? There is a difference between the guy who knows what he's talking about and the guy who faffs around. There's a difference between someone who stands and say, I know every detail of this. I mean, to a large extent, we won't know, you may not know everything, right, about, you know, the SIP protocol, but to a large extent, you're comfortable with, when you're troubleshooting, you understand what an M line means. You're not just talking to someone and say, okay, I'm using this IP address. I want to talk SIP with you, for example, on SIP terms. What are your M lines, okay? What is your connection info, okay? And I can translate that. I understand. I can work with that. That's how the protocol ought to work. That's how it's written to work, okay? And that's the reason why we're taking time today to look at the in-depth analysis of this protocol, that we might become a little closer, a little friendlier with it, okay? I'm getting a little excited now. All right. This is an example of an SDP offer, all right? And here you can see my M lines. In that M line, you say M equals audio. You say a port number. That's my dynamic RTP port number. You say an RTP/SAVP profile number, okay? And then after that, you see a series of numbers. What does that mean? The next thing we see a connection info, okay? Now, you can see following that, we see attributes. So each A, all those A's you see there, they're called attributes. Now, according to RFC 3264, each codec has to be defined with an RTP map. And these numbers correspond to what each codec should be within the RTP AVP profile. So 0 is for G7 language ULAW, 8 is for ALAW, 18 is for G729. Now, you will see, as we look at our case study, as we come into one of our case studies later on, you will see why it is important to even know what this number stands for, okay? And there's something I want to mention here. There's an attribute called FMTP. We call it format parameter. What is that for? As we know, we have two flavors of G729. For example, you have an NXA, G729, and XB. If a client or a server wishes to notify you that I can't do one or the other. For example, here you say A equals FMTP 18, Annex B is no. This guy is saying I cannot support G729 Annex B. Okay, that's what we use. We use to format parameter to extend our attributes in SIP. Okay, so another thing, another importance of that is in, if we look at where I put my arrow now, this RMT for RTP NTA, okay, we have a payload 101, but then we have our A equals FMTP 101 0 to 15. Now it's saying I can support DTMF event 0 to 15, 0 to 9, numbers star 11, and then 12 to 15 A to D, and sometimes you're going to say 0 to 16, and 16 is obviously for flash. Some people can, some vendors or some product can't do that. This is saying these are the DTMF events I'm going to support. So that's what we use FMTP for, to extend our attributes, okay? And the other thing you see is the direction. You see an attribute that say A equals send receive, A equals only receive only, or send only. It just says the direction of our media at that point in time. If you put a call on hold, for example, you're going to see A equals send only, because you're not receiving media, you're only sending it, and that's what that stands for. As you can see here, you can see A equals receive only as well. And here we can see our M line for our video. This is where we're going to be receiving video traffic, okay? And that's the port and that's the codec that we're going to use. This is what an SDP answer looks like, okay? I have sent a set of capabilities out there to you. What can you support? Okay, and then the server or the client, depending on the direction of the call, responds and say, okay, this is what I can support. Notice that the client has included both M lines for audio and for video. Remember what we said in the RFC. For each corresponding M line, we have to get the same corresponding M line in our response. Okay. There is this thing about early offer and delayed offer, and I just thought it's important to put it in here and discuss it. What is early offer and what is delayed offer? Please note that early offer is different from early media, and we will be discussing early media also, I think, in the next few slides. In an early offer, SDP is sent in the invite, okay? SDP is sent in the invite non-deliver. It's similar to H323 fast start. That's what it is. We want to send media in our SDP, okay? And then we get an answer in the response, in the 200 OK response. In delayed offer, an invite does not contain any SDP. So when someone asks you, what is the difference between early offer and delayed offer? This is exactly what it is. In one, we have SDP, we have media capabilities included in our request. In the other, we don't. And where we get an answer is very different in both scenarios. For example, in delayed offer, our answer is sent in the arc, because if I send an early offer to a service provider, I expect that in his 200, he is going to tell me what capabilities he wants to use. There has to be a form of response. And this is important because sometimes you don't get anything back. I've seen issues where you send a delayed offer invite, and then the 200 OK comes without any offer. And so if the call fails because there are no media, there's nothing we're going to, we can't establish any form of common ground. There are no media capabilities offered, and then we just drop the call, okay? Now, this is early media, and delayed offer calls do not set up media until 200 OK. That's what we know, call is answered. Now, if media is required prior to the call being connected, SIP has provisions for early media. With early media on a delayed offer call, the offer comes from the terminated side in a provisional response, for example, a 1A3 session progress. and the originating side sends an STP answer in PRAC. PRAC is a method, and it has its own RFC. And as you get the flow now, it seems as if every method in SIP seems to have its own RFC, and it is relevant, as I've discussed earlier, why we need RFCs for all of this. Okay. Now, one of the things, so why do we need early media? Think of this scenario. I call a provider. They're going to play some form of prompts to me, okay? My call is not connected yet. And so if there is no way for SIP for us to do early media in SIP, right? If we say, okay, I get it, if we do a 200 okay, at that point where my announcement is played, billing starts for me, which is unfair, really, because my call is not connected. All they're doing is announcement. So we're saying, okay, we want to play media before our 200 okay. That's where our billing starts, okay? So we find a way to do early media. We say, okay, we're going to use PRAC to do early media. And one thing is important to note is that, especially when you're integrating your SIP, using a SIP gateway with an ISDN, ISDN play an announcement. Usually when you do your debug ISDN Q931, you get something called call is not end-to-end. ISDN may contain inbound info. The moment you say inbound info, that suggests to you that the provider is playing some form of announcement, and therefore you need to enable PRAC. Otherwise, your call will not, you will have call failures. Okay, so that's the concept of early media in SIP. I did put the slide in here so that we'll have an understanding of how SDP is computed in SIP. Okay. Generally, when an endpoint registers the call manager, it advertises its capabilities to call manager. It says, I can support this codec, I can support that codec, I can support that codec. Okay. So when call manager is going to respond to an invite to a request from a cube or a third-party SIP device, it's going to use a combination of the capabilities of the endpoint and the region settings that have been defined. In fact, in one of our traces or in one of our slides further down, you are going to see how SDP is computed. So it's not just, you see call manager computing the SDP or the capabilities that it's going to use for the call, or the offer or the answer it's going to send to the far end, okay? And for cube or voice gateways, we use dial pairs and voice class codec. And this is where you can choose or influence what codec you're going to use for a call. I wrote a document a while ago on dial pair codec selection and call manager region settings. Someone asked, okay, who decides what codec we're going to use for this call? All right. This is what I'm talking about. You can decide. You can use, based on your knowledge, you can use, for example, if you configure a voice class codec with preference number and you send that to your ITSP, ideally, he needs to honor the preference, the codec that you have configured in your preference list, okay? And if it's, depending on the direction of the call, if it's an inbound call, the region settings determine which codec you're going to use for the call, things like that. So I wrote a documentation. If you're interested, you can have a look. Now, I'm coming back to the RTP AVP profile number because it's very relevant. It's very relevant. It's very crucial. I've seen two key issues. In fact, one of the issues we'll be talking about today, the vendor had to upgrade their core software altogether because it has been programmed incorrectly. Okay, and so it's important for us to know these things. So the RTP AVP number has its own RFC, and it's RFC 3551. And in there, 08, it's G711 ULAW, 1 and 2 are reserved, 4 is G723, 8 is PCM, ALAW, and on and on. And we have the dynamic ones, which is 96 to 127. So by now we know SIP is a client-server relationship. A user-agent client sends a request to a user-agent server. It's a client-server model, okay? And a user-agent server sends response to requests. Most SIP devices, they're both UAC and UAS. They both initiate and terminate requests, okay? And call manager and queue, they're back-to-back user agents, as we know, as opposed to proxies. Proxies most times do not send, or do not accept. They just forward. They see it as dummy devices, and they relay. We see VCS sometimes can be a proxy, or VCS itself can originate or terminate requests depending on what flow of call. If you are using a SIP-to-SIP call, for example, a non-traversal call, your VCS just becomes a proxy. It gets a request from, say, if it's integrated with Call Manager via a SIP trunk, or with any other device via a SIP trunk, it just gets an invite or a request from that end, and then it relays it to the far end. That's it acts as a proxy in that case. Understanding SIP traces. Okay, because of time, we're not going to look in detail at how we're going to look at how to understand SIP traces in detail. But I've written a document, one of my favorite documents, over the years, and I think it's been really useful to a lot of people. I think it's been viewed over 55,000 times, and I say this is one of the documents that have made me a little popular on Google. So if you Google understanding SIP traces, it's what comes up, or if you Google my name, I think that's what comes up with it. So it makes me feel a little cool myself. There's something somewhere in the World Wide Web my name can be mentioned or something. It's just cool. Don't mind me. I'm not vain or anything. I'm a very humble guy. But then I wrote another one, Understanding SIP, Expressway SIP Messaging. And the reason why I wrote that is because the concept that we're used to traditionally within Call Manager is not the whole scope of SIP. Within Call Manager, we do not see the proxy functionality, of SIP. In Expressway Messaging, we see a lot of the proxy functionality, especially in the Java Mobile Remote Access solution using Expressway COE. We see a lot of different things you're not used to. For example, you see a route header, you see a record route, for example, and you're wondering, I haven't seen that before in Call Manager or something. So the Expressway SIP messaging helps. I just went a little in detail into trying to elaborate on that side of the solution. So take a look. I think you will find it a little useful. Now, let's look at a SIP call flow, a SIP ladder, as we often call it. And this SIP ladder is courtesy of Translator X by Paul Gerald. It's a great tool if you want to know how to troubleshoot SIP and to give you a pictorial representation of what your traces look like. In the slide, we're going to see a few of the things that we've discussed, and it will come to life a little bit. So here we have 1, 2, 3, 4 IP addresses. Okay, this is a call between Call Manager and a service provider. However, the Call Manager, in this case, we have so the service provider is 172.27.50.23, and then our Call Manager is on 153.112.89.13. In between, so this solution utilizes two different interfaces. You have an internal interface and an external interface. That's why you're seeing 4 IP addresses here. There is an IP that connects to the service provider. There is an internal IP that connects to the Call Manager. So here you say instantly, you say invite with SCP. The moment you look at that, you say, this is early of our call. Okay? So you get it. You understand that, and you say, okay, I know from that I should know where my response is going to come from, okay? And then instantly we get a trine. And you see a little number in there, 1, 2, 3, 5. That's our command sequence for this. So we say, you see your command sequence for the invite, and remember the response goes with the command sequence, okay? And then you see in here, from there, so the call comes in from the service provider through the external interface 10.251.253.74, and then the call originates from the internal interface to the Call Manager, and then it forwards that call also with an invite with STP. We get a 100 trine, and then we get a 180 ringing. Some people, you may ask, yes, sir, what does 100 trine mean? You say this 100 trine. All 100 trying is doing for us, is to stop retransmission. You're telling the originator of the request, okay, I've gotten your invite, I'm going to do something about it. So don't send a retransmission. If we don't get a 100 try, you think, oh, you haven't gotten my request. And remember, we only do that for invite methods. For non-invite method, we do not get 100 trying, okay? So next we get a 180 ringing. So you get a flow of SIP now. I said an invite, I get a trying, I get a 180 ringing or 183 session progress. If you have SDP in your 183, and then you get a 200 okay, okay? So that's the flow, and that's how, you know, this is what this ladder represents. And you can see the proc message we mentioned there. In this scenario, really, there was no proc. There was really no SDP. This configuration just had it. So we proc, and then guess what? Look at the command sequence. It's different from that of the invite. Okay, so when you're looking at your traces, you know, this is not my invite. This is something else. Okay, and you can also see that the proc does not have 100 trying. It just gets a 200 okay. The proc, remember, is a non-invite method, okay? And then further down, we get a few retransmissions, re-invites going on here and there. Now, this is an interesting thing about this slide. You notice that all of my re-invites terminate on the internal leg of the gateway. It does not go back to the service provider, and this is because in this solution we've implemented what we call the re-invite / update, the mid-call consumption, mid-call re-invite / update consumption, because we found out that some providers do not handle re-invites very well. So there's no point sending it to them anyway, okay, unless we have a change in media, then we can send the invite out. And so the SIP ladder is great. You look at this, you get a pictorial representation of your call flow, what's going on. You see it instantly, and that's one of the things this is good for. So here's another polling question for us, and it says, how do you solve or resolve your SIP-related issues in your UC environment? A, do you come to the support forums? B, do you open a attack case? Do you look at logs or debugs yourself? Or do you look at logs, debugs, and then you come to the forum, or you go directly to open a attack case? The next slide, we're going to be talking about, case studies, troubleshooting methodologies. So I just thought we should, get a view, a feel of where you are, how you troubleshoot your SIP-related issues. Okay, here's my favorite. And here is where I want all of us to be awake. Let's go on this journey together. It's exciting. Troubleshooting methodology. I say to myself, are you an installer or a UC engineer? And I'm hoping today that I will inspire myself and inspire some of you out there to just, grab this thing by the bull, by the horns, and just say, you know what? I'm going to be a little different. I'm going to stand out from the crowd. Okay? Are you an installer? Anyone can install Call Manager. Okay? Anyone. You can just give people, you give them a media or a CD and say, you can have anyone can. But the problem is this: where do you go? Where do you start when things break? Where do you start to fix them? Okay, that's the difference between a UC engineer and an installer, as I call it. You can just, I can just configure a few partitions for configure this, configure keep. But hey, okay, my call forwarding is not working. What do you do? That's the difference. And I'm just hoping that you'll be inspired today to just go a little deeper and give yourself an edge in this area. So I say, have a holistic picture. You need to see things end to end. Have a holistic picture. Don't just say, this is where the problem is. I'll give you a good example. 2 days ago on the forum, someone came and said, all of a sudden my SIP phones are seeing the full URI of the caller ID. So instead of saying the number, you say the number and then you say the @ and the domain name. Okay, and the guy was freaking out. I said, why is that? So before you say, before we jump into conclusion and say, oh, I think it's the firmware of the 9971 phone, something wrong with them. The first question is this: are all your phones safe? And then he came and said, no. No, they're not safe. They're skinny. So obviously, you know that skinny phones do not understand URI. So they're not going to display the host portion of the URI. They're just going to present numbers. So that doesn't even tell us where the problem is. It doesn't tell us there's a problem with the safe phones. Okay? So we have two different protocols, skinny phones and safe phones. So the next question is, okay, let's take a look closer. Can you send us your traces, right? Let's see what is being presented to call manager as the caller ID. And that follows on from saying, okay, how do we present caller ID in SAFE? We have to know that if we want to know. And then we think, okay, so you go through a process of iterations in your head. You're looking at it. You're saying, I need to see it end to end. I need to understand it end to end. I need to know. So how do I present a caller ID? What header in SAFE do we use to present caller ID? And remember, we discussed this earlier. If we do not have the remote party ID, if we do not have the P asserted identity or P preferred identity, then we use a from header. And that was really where the problem was. Cube was not sending any of those headers down to call manager, and it was in the end it was a simple solution. Okay, you need to understand where the failure is happening, as I've just described now, and please, no wild guesses. Let there be a method to the madness. Don't just say, oh, the call is dropping. I think it's a codec issue. No wild guesses, please. We owe it to ourselves to be technically astute at what we do. We owe it ourselves to display a measure of excellence in our field of work. So don't just say, okay, yeah, they call, okay, I think it's this, I think it's that, no. We don't want that. We want to be people who knows exactly, absolutely what we are talking about. We want to come across as people who are knowledgeable, who are intelligent, and who go through a process, a methodology, before we arrive at a conclusion. If we say, I hear that guy coughing, it must be tuberculosis, right? Do you know how many people we have tuberculosis in the whole world today, right? Every one of us will be running on some form of tube or the other, isn't it? So that's how we have to approach it. No wild guesses. Let there be a method to the madness. Okay, now we're going to look at case studies. And I want to say thank you guys for staying with us so far. I hope you've enjoyed it as much as I have talking to you all. We're going to look at the case studies today, and we will be applying all of the things that I've mentioned, okay, in my case, all of the things I've mentioned in the slides and the case study. The first one we will be looking at is a SIP to H323 call failure. This happened on the support forum. So I'm going to read to you what the issue was. So the guy, one of the guys came on and said, I'm using call manager with H323 gateway to a Cisco 3825 running this iOS, and my call flow is H323 from the gateway to call manager and SIP to ITSP. When I attempt an outgoing call, I get mandatory IE missing error in the ITSP logs. He says, I've had this problem before with SAP trunk, and I was able to solve it by globally setting SAP with early offer force. What I've read is that they should fix it for H3 as well, but I'm not getting any log. I've done it, I've done this in call manager under the gateway. I've enabled MTP required and fast start. Now this is what I was saying earlier, right? This young man had a problem, and now it's wild guesses. Oh, let's try MTP. Enable MTP on the SIP trunk. Enable fast start. Enable this. What is the iterative process? How have you come to those conclusions? That's the question. Okay, let's dive into it. This is very exciting. It's very interesting. And let's see what happened here. Right, so we've got our invite from the ITSP. We've sent an invite. We've got try 100, and we take it off at the 200. Okay. Now look at this. in the SDP offer, we get our A equals RTP map 0 G79 8000. Now, I put in this slide that this is wrong. Question is, why is it wrong? What do you think? So from all the things we've discussed now, take a minute and think about it. Why do you think this is wrong? Okay? So let's go on. We'll come back to it. Now, call manager interprets 0 as being G711U law. Remember, in our RTP AVP provide 0 stands for G711U law. And this is why everything breaks. And then we see call manager selling, we see a TCS, the gateway interprets 0 as G711U law, and it decides that, okay, I want to use G711U law for this call. But let's look at the invite again. The invite here says G729. The provider says, I want to do G729. And the gateway says, I want to do G711U law. Okay? All right. So what happens next then? And then we say, so call manager comes back and say, okay, fine, you want to do G711 law? Yeah, I'm going to do G711U law also. And then we get, we get a TCS of G711U law, and then Cube sends an ARC back saying, G711U law. Okay? And guess what happened at the end of this? The call failed, and we get a normal call clearing. So what is wrong here? Remember that the RTP AVP profile number for 0 is meant to map to G711, not G729. So the provider they've incorrectly programmed their switch, okay, to use this. And they couldn't. The only way they solve this problem was to upgrade their switch. So this is an example of where I said it's all in the detail, guys. It's all in the detail. We need to pay closer attention. And this is why, the RFCs are crucial. Understanding what each component of your messaging, of your protocol does is very crucial. Okay, we were able to save this guy a trip to Cisco TAC by resolving this, resolving this. I resolved this on the forum for him. And it just, everybody was excited when we resolved it. And especially when it involves the provider having to rewrite their core software or upgrade their software. Okay, and this is also the importance of RFCs. So we know that you haven't implemented this as it is stated in the RFC, and credit to them, they acknowledge that. Our next case study is going to be a call failure with a DX80, which is registered on Call Manager and is trying to talk to a video bridge, which has a SIP trunk to VCSA. Okay, this happened in my place of work. Okay, and so what happened here? Okay, I pick it up again. So we get an invite from Call Manager. Okay, to the endpoints and an invite. We get a try-in, and then the VCSA sends an invite to the far end. Okay, all well and good so far. After I try and when 180 ringing from the far end, we get a 200 OK. All right, and then we see the next VCSA sends a 200 OK to the Call Manager. Okay, this is everything. This is what we're going to. This is the offer that we get from the far end. So VCSA here, it's a proxy. It's not doing anything. It's just relaying this message to Call Manager. Next. Now, something strange happened there. The far end did not receive an ARC to the 200 OK it sends. Then it sends another 200 OK. So I'm not getting an ARC to my 200 OK. I'm going to send another one. Okay? And VCSA forwards that to Call Manager. And then this goes on for about a minute or so. And this is the final 200 OK we get from the far end. Okay? Now, the question is this. Why is VCSA not sending an ARC to the 200 OK? Now, this is where the holistic picture comes to play. The answer is because it's not getting an ARC from Call Manager. So we don't stop and say, I think it's a VCSA problem. It's not sending the ARC. It should send an ARC. But why is it not sending the ARC? So we need to go one step further. So the answer, okay, call manager is not, we're not getting an ARC from call manager. So the question, why are we not getting an ARC from call manager? Okay, this is a fascinating bit. A look at the call manager logs reveal this. Okay, here after call manager receives this, it's the 200 OK from VCSA. It tries to construct its ARC. Remember, I mentioned SDP computation. So this is call manager trying to compute its SDP, where it's going to send the port number. You can see the remote RTP port number. You can see the audio line here, the remote RTP port number. You can see the M line for video here. This is call manager basically trying to, and you can see that it's an answer, it's an SDP answer. You can see here it says SDP answer. Okay, all right. So, however, before call manager sends his ARC, after computing it above, it needs to create a TCP connection to the address in the contact header. Okay. Now, you may be familiar or may not be familiar with this, but why is that? You can see it here. Call manager says event create connection to this address. Why does it need to create an address? Why is call manager trying to create a TCP connection to SIP? And here is the answer. In SIP, responses follow the via header, and future requests follow the contact header. Remember, ARC is a request, not a response. And remember, I asked us a teaser question to the other day. Why is the contact header, why is it crucial in 200 OK? Because that is where we need to send our ARC to. The ARC for a 200 OK will be sent to the URI of the contact header. You need to take this away because you don't know where you may experience this again. And the problem we have here is that the URI in the contact header, okay, is used. The URI in contact is used to route future requests. So when you get a reinvite, you get a buy. These are called future requests. And an ARC, we use the URI in the contact header to send our response. Okay, but traditionally the routing of SIP responses is going to be via the header. So you just need to know what is a response, what is a request, where am I sending, what is used to send, what is used in each case, okay? So one of the things I love about the support community is, you may ask, how did you know this? Is I came across this problem on the support forum one of these days when we were looking at the problem, and I discovered that, and so I went, I read up on it, on the RFCs, and lo and behold, a few days after, a month after, I had this problem in my work, in my own deployment. And this is why I love the support community. I think it's one of the greatest things, one of the greatest inventions within the IT industry. And I mean, forget about the invention of the Apple products, the iPad, and the iPhone and the iOS. Forget about that. I think the support community is one of the best things that ever happened. And guess what? I don't work for Cisco, and I'm not getting paid for this. So this is not a marketing, shenanigan, a marketing jingle or something. This is just me saying it as it is. You come to the forum, you see things outside of. You never know that you're going to experience that in your place of work, but just your interaction with that, you take it and then you take it to your own place of work, you become better, efficient, and your guys think, wow, this guy is good. That's what they're going to say, this guy is good. They do not know how you've come across it. Thanks to the support community. I'm sure some of you agree with that. Say, yay. And some of you say, what is he talking about? But it's all okay. Anyway. Case study 3 is we're going to be looking at CCNE. So I'm looking at different platforms to underline the fact that it's crucial for us to understand it because it cuts across different platforms. So we started with an issue with Cube, Call Manager. We've moved on to VCSC, and now we're on CCNE. Okay. Traditionally, I don't use the box CC poll, and it's important that you know that because it's very heavy. Okay, and if you need to configure the box CC poll, you have to configure logging into buffer. It's very crucial because it generates a lot of response, a lot of info, and you don't want to do this during production hours, especially if your gateway is a very busy one. But in this case, I had to use the box CC poll because I couldn't find what I was looking for in the box CC messages. And also, we do a show run. I asked the guy to do a show run. So what was the problem? The problem was all SIP calls, both internal and external calls, were getting cut off after 79 seconds. So what happened? Here's what we see in the logs, okay? We get options ping. So here's what we found out. After the call was connected, CCME sends option ping in its request to 9951 IP phone. We get a first option ping, we get a first retry, we get a second retry, we get a third retry, the sixth retry, and on and on, and the sixth retry. And then after that, CCME says, it is out of option ping retries, and therefore I'm going to tear down the call. You can see these lines highlighted here, out of retries, tear down call, and that's it. The call drops. So the question is, what's going on here? A look at the configuration shows that he had configured options ping globally on CCME. So what is wrong with that? Everybody using the options ping today. Well, options ping is meant to monitor the status of SIP trunks and not endpoints. Hence, the reason why the 951 did not respond to options ping. To resolve this, we had to disable options ping globally and then enable it on the dial pair that is facing ITSP. This is one of the great things also about the features in Cisco iOS, right? That you can configure your SIP parameters at the dial pair level, or you can configure it globally. So in this case, this just showed us that you need to know where you apply, because some things do not work well. If you don't want these parameters to affect the global characteristics of the call, then define it at the dial pair level. We're coming to the end of the slide again, and I hope you're still awake. Okay. All right. So this is SIP invite and outbound proxy issue. I'm going to say something here. Don't just copy every config you see, put it in your gateway. Ultimately, you're responsible for that solution. You're responsible for that deployment. And so don't just copy everything. Understand what each command is doing. Okay, I've seen a lot of people point outbound proxy on their gateway. They have no idea what it does. And this was a very difficult case for us. We saw this on the forum. Okay, so what happened there? Here, the guy came and said, okay, sorry, I don't know what's going on. My call is not working. I can't make outbound call. I can't get inbound call. Okay, so let's look at it. We had to look at CSIP all in this case because there were so many other things involved here. We had DNS SRV queries here, and I brought it also to show the DNS part of SIP as well. So here we get, we receive an invite. It's normal. We get a trying, and then we get an invite, and Cube sends an invite out to. So this is our invite. This is our trying, and then this is the Cube sending an invite out to call manager. Okay. Now, because the outbound proxy has been configured, Cube evaluates both outbound host and target host. So those are two things you need to know when you're using an outbound proxy. The target host and the outbound host are very, very different, okay? The target host is who the call is for. The outbound host is who the call should be sent to, okay? They're different. The call is for the target host, but who are we going to route this call through? It will be the outbound host. Okay, so here we see the target host is to 192.168.1.200. Okay, that is call manager IP address. Okay, however, we can see that the outbound host is a service provider. Okay, and because the outbound host is a DNS entry, Cube needs to resolve that. So let's see the DNS part of SIP. So we see here we see a DNS SRV query being sent. They send a query for _SIP.this and the domain, and then we get all the SRV records are returned for us. And then also Cube needs to do what? It needs to do an alias record check. So, we use SRV, we get the hosts are responsible for that service, and then we need to do a query for the alias record, and then we do a query for the A record, okay? So now we get the A record, the alias for the SRV, and that IP address is 204.111.92.170. That is where we will be sending this SIP request to. Now look at this. This is an interesting thing. So Cube creates a UDP, creates a connection to that IP address. Now it sends an outbound invite. Look at this invite. It says invite seems to go. We talk about our URI. So look at your URI here. We have the host and we have the user and the host. This URI is the host here is call manager IP address. It looks as though this call has been sent to call manager. So when we say, okay, let me get us call manager traces, we looked into call manager traces. There were the invite number came there. We're like, what's going on? This thing looks like it's going to call manager. No, it never went there. The actual fact is this call was sent back to the ITSP. So what we get next is we get a response back from the ITSP requesting authentication. And why is this? Because when we're using outbound proxy, we have a target host, we have an outbound host, okay? And all our requests will be sent out via the outbound host. So before Cube can send an invite out to the destination, it needs to do, among other things, the following. It needs to choose a transport protocol. Are we going to use TCP, TLS, UDP? It needs to do that. Then it needs to choose a target host. And then it needs to choose an outbound host. If you do not have SIP proxy, if you do not have outbound proxy configured, I believe your target host and your outbound host will be the same. So, and then it needs to establish a connection to the host. Okay. If you need to use an outbound proxy, you need to use no voice class SIP outbound proxy on the dial pair to call manager. Okay, so that all traffic going to call manager are not routed out back to your ITSP. Okay, excellent. So this is me coming to the end of the presentation. I do hope you have, you found it useful. And these are a few references for you. I mentioned some of them in the course of the presentation. Understanding SIP traces, and then I wrote one on Cube SIP. The SIP signaling and media binding to an interface. A lot of people have found it very useful, especially when you have multiple interfaces on your gateway. You need to know where your SIP signaling is going to be sourced for. You need to know where your media will be terminated on. You need to choose it, because if you don't configure this correctly, sometimes you have one-way audio issues. And then DTMF negotiation. We didn't get to talk about DTMF today. It is a very, very crucial part when we're dealing with SIP integrations. Okay, so Lavanya also has written a very excellent documentation on DTMF negotiation, and you will see them under the document and the blog feeds on the CSE IPT forum. Also, I mentioned about the expressway SIP messaging, and then another one talking about SIP trunks and run on all active unified call manager node. Thank you very much, guys, for listening. I hope you've gotten something out of this presentation. Thank you.
Thank you, Deji. Great presentation, really great presentation. I want to thank everyone for participating in the event polling. We were going to answer some Q&A, but we ran out of time for that. But we will be answering those questions. Deji will be on the community. So we'll take all your questions. If you can take those questions that you posted in the Q&A on this webcast and go to the community, and you can go to our knowledge sharing area in the expert corner and look up his Ask the Expert event, and you can post them there, and you can get detailed answers there. So we'll answer all your questions at the follow-up event. So I want to thank you for attending. This is going to conclude our portion of today's event. So we have a trivia question. What do Verizon and Cisco have in common? And A, Cisco and Verizon Wireless are working together at the LT Innovation Center. B, our expert for today's webcast is from Verizon as one of the Cisco designated VIPs. C, Verizon has been a Cisco partner since 1992, or all of the above. So take a moment to answer that question, and we'll give you the answer a little bit later. And we want you to visit the Cisco support community. We encourage you to do so, and we have a brand new look and feel and increased options and features, so log in and start sharing today. And, of course, be sure to join the Cisco support community where you can share current real-world technical support knowledge with your peers and experts, and you can also participate in live interactive events like the Ask the Expert event that Deji is going to host after this webcast. And And you want to check out the Class of 2015 Event Top Contributors and Spotlight Award winners on the Cisco support community. If you're interested in conducting an event for us and becoming a top event contributor yourself, please go to the Experts Bureau and sign up. And our presence in social media keeps expanding, so we encourage you to visit the community and join us through our social media channels. We continue to expand in many other languages. We have also recently launched our Chinese community, so please be sure to stop by and browse through it if you speak Chinese. We also ask you to take a moment to rate the content of your peers, documents, videos, and blogs. In doing so, you'll help us recognize the wonderful content that they contribute. And if you're looking for more information on IT and technical training, log into our Cisco network, learning network, and take advantage of the technical webinars that they offer. You can go to the link provided in the chat to learn more. And now the answer to today's trivia question, it is D, all of the above. Cisco and Verizon Wireless are working together at the LTE Innovation Center. Our expert for today's webcast is from Verizon, is one of the Cisco designated VIPs, including the new class of 2015. And C, Verizon has been a Cisco partner since 1992, so all of the above. And before signing off, please take a few moments to complete your evaluation of today's session. This will help us address your business needs and interest in the future. And this concludes our session today. I want to thank Ayodeji Okanlawon for sharing his expertise with us today, a very great presentation. I also want to thank experts Lavana and Raphael for answering your technical questions. I want to thank you all for attending and have a wonderful day.